Students, now let us look at the model for intermodal selection. This model would be applicable for selecting the intermodal services. The model actually uses cost minimization as the objective, assuming that the shipment is not split between modes. So the basic assumption of this basic mathematical model would be that you will not split the shipment between the modes. So that means when you are switching the mode of transportation, there is no shipment splitting for this basic model. The entire quantity is transported with use of only one mode between any two cities. And then also transportation costs are assumed to be linear with distance. So this basic model doesn't take into account the non-linear nature of cost if it exists for your type of transportation. So this model is a simple model that assumes that there is no shipment splitting between a city pair and the cost is linear in nature. Now let us look at the model. In this model, Cij plus 1k is the transportation cost from city I to city I plus 1 for mod k. It should be city I to city j plus 1. Then we have Tikj, that is the cost of transferring from mode k to mode L. It's Tikl at city I. So when you are transferring the mode, or you are switching the mode from K to, let's say, mode L, from truck to, let's say, rail at some city I, the cost of transferring would be Tikl. And the decision variables would be the assignment decisions. That is, xi, I plus 1k would be either 1 or 0. It would be 1 if mode k is used to transport goods from city I to city I plus 1. Otherwise, it's 0. And yikl would be either 1 or 0. It would be 1 if goods are transferred from mode K to mode L at city I. It would be 0 otherwise. So if goods are transferred, then that if you change the mode of transportation, then it would be 1, x would be 1. And if goods are transferred as well from that mode to the other mode, then y would also be 1. Otherwise, both would be 0. So that means this model would be applicable when you have intramodal services as well. Because in case of intramodal transportation, your x and y would be 0. Now, the overall minimizing z function would be the minimum of sum of I, sum of k's, for xi I plus 1k into cii plus 1k plus sum of I, sum of k, sum of L for I yikl tikl, subject to the following constraints. And the constraints would be that sum of k for xi I plus 1k should be equal to 1 for all i's. And of course, sum of k into sum of L for yikl should also be equal to 1 for all I. And xki minus 1 to I, that is from the previous city to the next city or to the current city, plus xi to I plus 1 L, that is from the current city to the next city, should be greater than or equal to 2y ikl for all I, k and l's. And of course, YIKL XII plus 1K belongs to 0 or 1. They are either 0 or they are 1 for all I, K and L. Now let us clarify what does these constraint actually means and why are these constraints are in place. The first cost term on the right hand side is the sum of total transportation cost. So in the objective function, the first term is actually the sum of total transportation cost that is to be transported from the origin to destination. Then the second cost term on the right hand side is the sum of transfer costs. So the first part is the total transportation cost. The second part is the total transfer cost when you are switching from mode K to L. And if the shipment is transferred from one mode to another at intermediate cities, the first constraint actually specifies that only one mode is selected for transporting goods between two cities. So the sum of all XII plus 1K actually ensures that this one mode of transportation is selected. You didn't select when you are switching from one mode to another. You are not selecting more than one mode. This ensures non-splitting of the shipment between modes. The second constraint specifies that only one type of transfer take place at city I. Only one type of transfer. And the third constraint ensures consistency. If at city, let's say J, there is a modal transfer from K to 1, then city I to J, the goods are transported by using mode K. And from J to M, the goods are transported by using mode 1. The final constraint is simply the 0-1 constraint for the decision variables. The optimal solution to this problem would yield a set of 0-1 values, which would determine the optimal mode for each city pair. What does it mean? इसका मतलब क्या है? इसका मतलब ये है कि it's a essentially a 0-1 assignment. तो आपके हर city pair के लिए you will get actually one mode of transportation. And mind it that it might repeat for some other city pair as well. So students, we have seen the basic model. So we have seen the basic model for intermodal selection, which is essentially a 0-1 assignment for different city pairs and different modes of transportation. Thank you.